In video 2, we're going to discuss something called angle of inclination. This is a pretty straightforward and hopefully a short topic. The angle of inclination, you can see the definition down here, is the angle measured from the positive x-axis, so it's always out here to the right, up to the line, no matter where that line is. So you can see a picture here. This is in quadrant 1. This slope is positive, and there's your angle of inclination. In this example, we see there's a negative slope here, so you have to go a little bit further to get the whole angle. That's going to end up in the second quadrant. If I draw in kind of a fake axis here to think about the unit circle, we go through the first quadrant into the second quadrant. For all of these, no matter what the line looks like, your answer is going to be between 0 and 180. The function that we use in order to discuss angle of inclination is tan. It's always tan, that's it. That's the only one we're going to use. If we go back to chapter 7 a little bit, and you guys all got pretty good at this, if we label these sides as x, y, and r, and think about what we know that our slope is the rise over the run. If we translate that into this triangle, our rise here is y, and our slope is x. We know that y over x is the same as tan theta, so that's what we get up here, that the slope of the line equals the tangent of the angle of inclination. So that's important formula number 1 that we need to remember. We can also do this backwards. So the last slide we just discussed that m equals the tan of theta. We take the tan inverse of both sides, and this is what usually happens more often. If you're given the slope of the line, or if you can find the slope of the line, and you take the tan inverse, that'll give you the reference angle. And then from there, you just need to make sure that your answer fits between 0 and 180. If you're given a negative angle, and we'll take a look at what that looks like. So let's say they give me an angle of negative 24 degrees. Well, if this is my line, what I really want is this angle up here, where right now I only have the negative 24. To get from this point all the way to this point, I want to add 180. So that's what we're going to do if it gives you a negative angle. So let's take a look at a couple examples and then we'll wrap it up. So for these first two, it's asking us what the angle of inclination is. That means I'm looking for theta. And again, we can find that by taking the tan inverse of the slope. So the first thing we need to do is figure out what the slope is. So for the line joining negative 3, negative 5, and 3, negative 3, if I do y2 minus y1 over x2 minus x1, I end up with 2 over 6, or 1/3. Again, my slope is 1/3, so I'm going to take the tan inverse of 1/3. When I plug that in, my calculator will give me 18.43 degrees. That's in between 0 and 180. This is in the first quadrant because the slope is positive. So we're all set there. That's your answer. For the second one, it says the line perpendicular to 3/4 x minus 8. So we know that the perpendicular slope of that line is the opposite reciprocal. So it'll be negative 4 over 3. We're going to follow the same process and take the tan inverse of negative 4 over 3. What your calculator gives you for that answer is negative 53.13 degrees. We talked about this, that if the slope is negative, so a line like this, that means our answer is going to be, we have to go a little bit further to get there. So if it gives you a negative, you can add 180 degrees to that. And our final angle of inclination is 126.87 degrees. So that's going one way. We were given the slope, or at least able to find the slope, and then we found the angle. Now we're going to do 2 more going the other way, and that's it. When you're given the angle, whether they're asking you for the slope or the equation, we need to figure out the slope at some point. We know that the slope is just the tangent of the angle. So this first example is very straightforward. What's the slope of a line with an inclination of 73 degrees? We would just take the tangent of 73, and we end up with a slope of 3.27. Second example, there's going to be another step. I'm just going to slide this out of the way so we can see this, have some room to work. What's the equation of a line with an inclination of 123? So first let's find the slope. I'm going to take the tan of 123, end up with negative 1.54. So I know that that's my slope. Question asked me for an equation of the line, so we need to do a little bit more work. We know it's going to pass through negative 9.5. The easy way to do this, and most people are a little less familiar with this, but point slope form is y minus y1 equals m x minus x1. So if you use that negative 9, 5 is y1 and x1, you can write y minus 5 equals negative 1.54, and then x plus 9, since it would be minus negative 9. That's a perfectly good equation for this, and I would absolutely take that as an answer. If you're not comfortable with that, you want to do slope-intercept. It's definitely a little less efficient. But you could take, we know this is y equals mx plus b. We could say that y is 5, m is negative 1.54, x is negative 9, and we're trying to find b. Once you work that out and do the algebra, you end up with an equation of negative 1.54x minus 8.86. So it's doable either way. If you can get comfortable with point slope, it'll make your life a little bit easier. But that's the idea for this type of problem.